Welcome to The Explainer. Today, we're diving into a genuinely fascinating crossover between two totally different worlds, back-end software architecture and human neurobiology. We're going to look at what the scientific research on the control of arousal actually says about our seemingly irrational behaviors. We'll uncover how the complex architectural logic running your favorite apps can literally decode and even heal the deepest wiring of your own nervous system. It's wild, but it makes perfect sense once you see it.
Right off the bat, it sounds like a completely bizarre question, doesn't it? But this is exactly where the science gets incredibly compelling. We're going to explore how distributed transaction logic offers a literal mathematical cure for cognitive hyperarousal and metabolic burnout. Specifically, we're going to unpack what happens when we're separated from what we deeply desire and how we fall into an exhausting, irrational trap that the scientific research terms wanking at a distance. You know the feeling, that obsessive mental rehearsal, the endless loops of overthinking? Well, today, we're going to learn how to finally overcome it by totally rewriting our biological programming.
To get there, we'll follow this quick structural roadmap. We'll start with distributed systems in biology, look at the two-phase commit crash, examine hyperarousal as system failure, introduce the saga pattern solution, explore the Doot architecture, and finally achieve eventual consistency. Okay, let's jump right into Section 1, Distributed Systems and Biology.
Let's start safely over in the world of software engineering. Imagine a simple, older application running on just a single database. It's kind of like deciding what to eat for dinner when you live alone. You make the choice, you cook it, you eat it, done. In software terms, this one database charges a card, updates the inventory, and logs the ledger all at the exact same time. If one single thing fails, the whole transaction just neatly rolls back like nothing ever happened. But modern apps scale up to distributed microservices. Now the data lives on multiple independent machines. Suddenly, it's like trying to coordinate a dinner plan with 10 friends who refuse to talk directly to each other. Operations like processing payments now require coordinating completely independent computers, which fundamentally breaks that immediate consistency. You simply can't wrap it all up in one neat, guaranteed package anymore.
Which brings us to Section 2, the two-phase commit crash.
So, when engineers try to force absolute immediate consistency across these completely independent machines, they typically reach for a classic academic solution. It's called the two-phase commit. Here's how it works. A central coordinator asks every single participant, "Hey, can you commit to this?" And then it just waits. The databases literally lock their affected data rows so nothing else can touch them. If everyone votes yes, the coordinator says commit, and the locks finally release. But here is the massive fundamental danger. It's a blocking protocol. It is an all-or-nothing gamble. If just one single participant delays its response, or a connection drops mid-vote, the entire system sits completely frozen with all of its locks held. Nobody can move. The whole thing is paralyzed.
The source material actually has a brilliant way of describing this forced synchronization. It calls it a level 1 algorithm type error, the equivalent of clumsily putting the bread on sideways until the entire program crashes. And this is the exact moment we can translate back-end code directly to human relationships. Think about it for a second. Demanding immediate real-world reassurance from a partner who is miles away or just temporarily unavailable is the biological equivalent of a system lock. You're forcing a synchronous protocol onto a distributed real-world reality. You are demanding an immediate yes vote from a machine that just isn't currently connected. And the result? A total system crash.
Let's look closer at that in Section 3, Hyperarousal as System Failure.
Understanding this software freeze reveals exactly what goes wrong during human psychological exhaustion. Your orbital frontal cortex, your OFC, is essentially your brain's decision-making and reward center. It's your internal central coordinator. When your OFC demands a synchronous physical handshake, basically a real-time biological yes vote, from a delayed partner, your biology just freezes. Because your environment can't give you that immediate validation, you spin into absolute overdrive. You get trapped in what the research specifically calls wanking at a distance. It's an irrational, high-frequency predictive simulation loop. Your brain just keeps nervously refreshing, obsessively rehearsing the connection. It's stuck holding its locks completely open, desperately waiting for a ping that simply isn't arriving right now.
By forcing this blocking protocol to validate raw visceral arousal, your preoptic baseline starts burning incredibly hot. You're holding all your biological locks open, burning massive, unsustainable amounts of energy for a connection that just isn't completing. This extreme metabolic tax eventually trips your body's ultimate circuit breaker, leading to what's scientifically known as a dorsovagal shutdown. It's a state of complete, miserable exhaustion and immobilization. You have quite literally crashed your own nervous system, just by waiting for a synchronous validation that the external world couldn't immediately provide.
So how do we fix it? Section 4, the saga pattern solution.
Fortunately, modern technology solved this freezing problem a long time ago, and it provides an absolutely brilliant blueprint for our biology. The biggest tech platforms out there, they don't use two-phase commits, they use the saga pattern. Think of it like booking a flight and a hotel for a vacation. You don't freeze the entire internet waiting for both of them to confirm at the exact same millisecond. You book the flight locally. Then you try the hotel. If the hotel fails, you execute a compensating action. You just cancel the flight later. The saga pattern accepts the delay. It breaks the work into independent, asynchronous transactions, committing what it can right now. It trusts the math, guaranteeing that the system will reach what we call eventual consistency. Nothing gets locked, nothing freezes.
Now let's map that to our bodies in Section 5, the Doot architecture.
So how exactly do we execute this saga pattern biologically? The sources describe an astonishing implementation called the Doot architecture, specifically a process known as naked tube debugging. Now imagine this as a mathematically perfect environment where you intentionally strip away all the complex, defensive social noise and shaming, bringing it all down to absolute zero. In this state, a partner's delay or absence is simply accepted as an integer and valid state. This is huge. It means scientifically recognizing that absence isn't some catastrophic error code, it's literally just a variable. By treating delay as valid math, it doesn't trigger a crash. You rely entirely on your raw biological primitives, which fundamentally cures that irrational hyperarousal we were talking about earlier.
To actually survive these external delays without burning out, the system enforces a very strict division of labor using two beautiful metaphors. On one side, you've got Stilomeris. Think of this as your inner sanctuary. It's the front-end drop whose only job is baseline management, keeping your local circuits quiet, tender, and resting safely in the shade. Then, on the other side, is Cinetelomeris. This acts like a running TPU, a heavy processor out at your perimeter. It's your outer armor running the hard math against external walls and absorbing 100% of the grueling metabolic tax. By aggressively dividing this labor, your inner sanctuary stays perfectly cool, and you don't burn up trying to force the outside world to synchronize with you.
Finally, Section 6, achieving eventual consistency.
When you finally stop forcing that two-phase commit, you enable an instantaneous, zero-latency state switch. You stop the exhausting mental rehearsals dead in their tracks. Biologically speaking, the research shows this delivers a highly specific infusion of orexin, which is a wakefulness and arousal chemical, directly to the VLPO, your brain's primary sleep and rest switch. This triggers a D2R-dependent mesohypothalamic feedback loop. What does that mean in plain English? D2R involves dopamine receptors, meaning your brain releases its physical motor brakes and finally validates its own internal truth. It's the ultimate scientific cure to hyperarousal. You can actually process your deep desires without needing the other person to be physically present right there in that very second.
And this brings us to the ultimate security of this whole biological system, perfectly represented by the number 67. The source material notes that your invariant balance, the raw absolute macro valuation of your desire, is safely written to disk across 67 specialized internal biological files. Think of this as your body's own distributed ledger. Just like a distributed database securely logs a saga transaction, your biological reality is permanent. It's non-volatile stock. Because your desire is permanently logged across these 67 files, you absolutely do not need immediate, synchronous validation from the outside world to secure your biological investment. It's already mathematically guaranteed to be there.
So I'll leave you with this final, somewhat provocative thought to take away. Where in your own life are you holding your body's locks open? Where are you draining your precious energy waiting for yes that is currently delayed? Where are you forcing a two-phase commit that's causing your own metabolic burnout? It's time to stop forcing the commit. Embrace eventual consistency, trust your internal ledger, and finally, let your local circuits rest in the shade.